Hey, what's crack-a-lackin'? It's a beautiful late winter's morning out here in the LBC. So I chose a pretty curious place to biologize today. I'm basically out here in the middle of this industrial slash utility area. So in this particular region of the world, this is kind of like my hometown region and everything. And after, finding myself during one of those nights where you go down that internet wormhole, I was going down an internet wormhole about the city of Long Beach and surrounding areas where I'm from and everything like that. And just kind of get an idea of the overall history slash natural history of the place. So what I learned and what I found out that a lot of people don't know is that a large portion of the city of Long Beach was actually built over a salt marsh area. So you can imagine that the overall topography of the place was basically kind of low lying, like very low. And in some cases, in many places, is below sea level. That's why a lot of times when we get heavy rains out here, there's a lot of nearby communities that can get flooded out and everything. But you can obviously see around me that it does not look like a salt marsh today. I mean, you can see we got some energy infrastructure here and, some industrial businesses over there, power lines and everything like that. Just overall like standard like kind of urban area where not a lot of people live per se. There's just a lot of business going on around here. But that does not mean that nature will not take advantage of this stuff. And we're going to try to see what nature can be found out here. What is taking advantage of this current ecology in this particular space and time. I mean, as far as vegetation goes, you can already see that it's pretty sparse out here. A lot of the trees that you can see, a lot of them are ornamentally planted, whether they be native or non-native species. But we're not going to concern ourselves with what was planted on purpose, by people and everything like that. We're gonna look at the feral stuff, like the stuff that just got here on their own, so to speak. Okay, so starting with this fence line right here. So I want you to imagine, like, when it rains out here, that as the rain is falling down, it's gonna hit this fence. And the fence is basically going to act as a water collector in some way. Like it's going to hit the fence and then it's going to dribble down the fence on the ground. So you can imagine that in a way, areas around the perimeter of this fence are going to hold water to a certain extent more than out in this bare ground area. And you can see with that explanation that I just made how the weedy vegetation can take advantage of that particular ecological thing that goes on. So one of those weedy plants we got right here, this is a species of Erigeron. I'm not exactly sure which one it is. It's either like sumatrensis or bonariensis, I think. I know it's not the native one, canadensis, because of that hairy stem right there. Family Asteraceae, and a very strong weedy species in this particular region of the world. And it seems to be doing pretty good along this fence line, along this ecotone, essentially going from the fence to this gravel to more of this like silty structure. So I have a feeling, you can see right there that there's some moisture on the ground and everything like that. So you can see how this Erigeron would like hold up in this particular microclimate, slash micro topography that allows like water to kind of hold up here for a little bit longer than it normally would if this wasn't here. Oh, and look what we got here. So what we got right here is undoubtedly Latrodectus geometricus, aka the brown widow, introduced species out here in Southern California, as opposed to the black widow. And the way you can tell it's a brown widow, not a black widow, is you see that dorsal kind of longitudinal white striping that goes around the dorsal part of its abdomen. See how it's like broken up towards the anterior end? Yeah, that's how you know it's a brown widow. If it was a black widow, that line would be solid. But yeah, family Therideidae, or the family of comb-footed spiders. I think considered by most arachnologists to be the sister taxon to the orb weavers. So however many million years ago, orb weavers and Therideids had a common ancestor where they split. So this will grow up to look more or less pretty much the same color pattern and morphology as you see right now, and because this is a juvenile, as opposed to like black widows, or at least the female black widows. They'll obviously get darker and more black. Brown widows can also do the same thing. Some individual brown widows, as they age, especially the females, will get darker in coloration. Supposedly the venom of this species is more toxic than our native black widow, Latrodectus hesperus, but I don't think there's any evidence to really show that they've caused like serious harm with people. Yeah, brown widow, Latrodectus geometricus. Probably the most common spider you're going to see in Southern California, especially in urban areas. All right, as we move down this fence line, we can see we have another very prominent weedy species that can be found out here. So this plant is Lactuca seriola. I think it's Lactuca seriola, otherwise known as wild lettuce. So this is basically the plant to which like lettuce has been cultivated, how it was bred and artificially selected for to become the lettuce that we know and eat today. So I think it's called Lactuca seriola because of these kind of like spines on the ribs of the leaves. Kind of gives it like, you know, a serrate, saw-like appearance. I think that's why it's named seriola. But not really particularly sharp or anything like that. I mean, you can see I could like just like rub them off. Like sometimes they stick in your skin, sometimes you feel it, and sometimes it's a little painful. But for the most part, it's pretty soft. In case you're wondering, yeah, it is edible. You know, during this time of the year, you could easily harvest and forage for, you know, weedy plants to make a salad. You don't want to do it as this plant gets older though, because the leaves become much more fibrous and, you know, harder to chew and everything like that. It's only the young ones you want to eat. Family Asteraceae, so the daisy family. Again, another Asteracean over here, just like that Erigeron. And looks like there's a bunch of them growing along this fence line. So it seems like this particular spot of this fence is favoring this Lactuca. Oh, and I just noticed we got another Asteracean. Looks similar to that Lactuca, but this one's in a different genus. I believe that this is Sonchus oleraceus, also commonly known as sowthistle. So again, family Asteracean. This one is so fortunate to be flowering, so you can see that composite flower right there. But again, another common weedy plant taking advantage of the microclimate created by this fence. Okay, so I moved over to this vegetation patch because it looked pretty interesting because I'm seeing a lot of native vegetation here. Now, I'm not sure if this was purposely planted. In my opinion, I highly doubt it. I also wonder if this is kind of like a fragment of what was left behind from the original native community that was here. Typically in a lot of suburban areas, you will find little small, like really small fragmentations of the original habitat that used to be here. And the reason why I think that this might be a fragment of that is because it's by far dominated by native vegetation. So first one up, we got this. This is Baccharis salicifolia. Common name is also called mulefat because apparently when people had mules, they would eat this stuff and they would get bloated. So it would like literally make mules fat. And if you notice on some of these leaves, it kind of looks like it's got like a little herpes infection or something like that, but it's not infected by a virus. It's actually infected by an arachnid, a type of mite. And the name of that mite is Asaria Baccharisis. Baccharis because it's typically associated with Baccharis. But yeah, what that little tiny microscopic mite will do is bite the plant, and the bite basically causes, you know, a reaction, almost like an allergic reaction in the plant, where it produces like this wart-like structure. And then that mite will live its life in that wart structure because it provides a certain amount of protection. And then in turn, it can basically feed on the plant at will without being harmed by anything that might want to try to eat it. So again, family Asteraceae, and you can see right here some of the old flowers, those old phyllories right there. And then we have some new, this season's flowers about to start flowering. Yeah, Baccharis salicifolia. And the second dominant plant that I'm seeing here is this. This grass is Muhlenbergia rigens, aka deergrass, Poaceae grass family. Anyway, so that's what the inflorescence would look like, or the stalk, the spike, I guess, or spikelet. There's different anatomical terms for grasses compared to other families of plants. It's kind of crazy. Look how dense it is, though. I wouldn't be surprised if this little stand right here is providing habitat for a couple of mammals or something like that. Probably rats, Rattus norvegicus. You know, the introduced rats that you would find in your house and everything. I wouldn't be surprised if rats are the dominant mammal that have taken over this spot right here and everything around us. Okay, right there we have Buteo lineatus, aka the red-shouldered hawk, family Accipitridae, or the family of true hawks, I guess. This is actually my favorite hawk, or at least my favorite hawk in California. It just looks the prettiest to me. That's all. This is a more like kind of broader, robust, medium-sized hawk, I guess. You'll easily find a lot of these in the suburbs, and they're particularly active this time of year, early spring, late winter, feeding on all the squirrels and rats and everything like that cities typically have to offer. It's an excellent predator on rodents. I've seen these things take out squirrels plenty of times. Falconiformes, which is the order of diurnal raptors, as opposed to the Strigiformes, which I guess would be owls. Those would be like nocturnal raptors, at least nowadays. There are some diurnal owls though. But yeah, Buteo lineatus, the red-shouldered hawk. All right, so I moved to this little shady section because it was getting kind of hot out there, but I noticed on this wall, okay, so right there we have Scoloporus occidentalis longipes, subspecies of fence lizard known as the Great Basin fence lizard. And although we are far from the Great Basin, like about 300 miles away from it, um, this species is still lumped into that group. I guess genetically they share more similarities with those populations as opposed to like the 2 or 3 other subspecies. I mean, only naturally I gotta question that though, you know? Like, I have a feeling, especially with the amount of habitat fragmentation that occurs in urban areas, you know, I would not be surprised if there are at least like genetic distinctions in certain populations out here. Not saying that they would warrant their own species or anything like that, but I guess I just question how much, you know, certain isolated populations will actually like interbreed with each other, and whether it's acting as like, you know, the basis for like a speciation event or something like that. You know, maybe we'll get noticeable phenotypic differences within, you know, urban, little small urban populations of lizards. I'm just daydreaming. Okay, this plant right here is interesting. And it's interesting because I know that this was not planted here on purpose. This was produced here naturally and probably was deposited here as a seed that transversed its way through the gut of some type of bird. But anyway, this is Washingtonia robusta, also known as the Mexican fan palm. California has its own native species of palm too, Washingtonia foliifera, but their native range is actually found in like desert regions and everything like that. I'm sure many of you have heard of the city of Palm Springs. Yeah, so Palm Springs and areas around the desert region have pretty nice examples of palm oases, where you can see like native palms. There'll be native palms in the city too, but you know, you kind of need a hard eye to tell the difference between the two. And one of the ways I could tell that this is robusta and not foliifera is because of the color of the petioles right here. You can see that it's mostly like brown. On the native one, it'll be mostly green and everything. And then also robusta has these like pretty robust, like thorn-like protuberances coming off of that petiole. Pretty menacing looking, I must admit. Okay, I was just walking and this beetle landed on me. I think it's a type of Eucalyptus beetle, although it looks a little different from ones that I've seen before. Definitely family Chrysomelidae. At least I'm pretty sure it's Chrysomelidae family. I mean, you can kind of see like where its antennae like kind of hit its face, where it comes out its face. They kind of come together. That's somewhat of a distinguishing characteristic of Chrysomelids. Okay, so I think this is Paropsis altimaria. Common name of this, I think, is the dotted paropsine leaf beetle. And yeah, it is associated with Eucalyptus, and it is an introduced species out here, you know, likely taking advantage of the eucalyptus that are ornamentally planted, especially out here in Southern California, actually all of California. And, you know, it makes sense. You know, you bring a new species out and, you know, you can almost bet that the species that exploit that in their home range are also going to exploit them in their introduced range. The Chrysomelidae is actually a pretty cool family of beetles and everything. Like, a lot of them do pretty cool things. Like, if you see right there, the tarsal claws, or the segments like right next to the tarsal claw, basically the terminus end of its feet. You can see how they're kind of like enlarged and widened. Well, that, you know, that helps them grip, you know, kind of almost like the same concept as the toes on geckos and everything like that, you know, increased surface area, which allows for increased adhesion to whatever you're trying to stick to. And in this case, it's sticking to my finger. But yeah, Chrysomelidae, you know, that's a pretty huge beetle family, and there's a bunch of cool ones out there. They got, you know, not just cool designs and cool colors, you know, metallic colors and everything like that, but they also do cool things. Yeah, there's a species of tortoise beetle out there, also in the family Chrysomelidae, that is basically kind of immune to ant attacks. Like, it uses those feet, the suction on those feet, or the adhesive properties on those feet, to kind of hunker itself down on the leaf or whatever it's on, and then ants would come by, predatory ants that would try to pry it off, and because of those adhesion properties, it can't do it. Oh, you could actually see its mandibles right there. It's cleaning its mandibles with its front feet. You can see how those mandibles are shaped, kind of like broadly tipped, almost like, you know, kind of truncate, maybe like somewhat toothed. Yeah, Paropsis, spotted leaf beetle. All right, traffic's starting to build up, but I'm looking at across the way over there and I'm seeing these puddles. I kind of want to go check those out. Let's make sure it's safe. Cross the road. I knew it. I knew it. I knew I had to come check this out. I knew there was going to be stuff in these puddles. You see, this is why I like life and living things and biology and everything like that. Because, you know, you come out to an area like this, which is, you know, obviously being cleared by human disturbance and everything. And, you know, we had rain about a few weeks ago, and the rain caused these puddles. And within the few weeks that these puddles remain here before they dry up, you know, there's a whole freaking universe ecosystem that was created here. So first of all, what you're looking at is a modern example of a vernal pool ecosystem. Vernal pools are basically depressions in the ground that usually fill up with rainwater. It could be snow melt water too and everything. But those depressions, you know, once they fill up with water and once they've held water for a significant amount of time, begin the process of creating a very specific ecosystem that favors very specific taxa. And just looking at this straight up, it seems like this particular puddle is hustling and bustling when it comes to the activity. I'm seeing all sorts of stuff right here. So what I'm gonna do is I'm gonna go get my net, and I'm gonna take some samples, put them in a little viewing dish, and try to identify and see what we got living in this modern vernal pool system right here. I hope I don't find an endangered species. If I do, it's gonna be a problem. Okay, first things first, get my little watch glass, a little bit of water. Here we go. Here's what we found. Seems like we have, let's see, 1, 2, 3, about 4 different taxa that call these puddles home. All right, so the first one I want to talk about are those kind of like upside down swimming, kind of looking like ghost looking things. So those currently are classified in the Crustacea. However, as more studies ensue and more evidence comes out, it turns out that these organisms are probably more related to insects than they are other crustaceans. But anyway, they are in the order Ostracoda, which is the order of fairy shrimp. And this particular species, judging by looking at the male, that's the male swimming around right there. This is Branchionecta lindeli, otherwise known as the versatile fairy shrimp. And there's a good reason why they're called versatile fairy shrimp, because they are very versatile in where they can be found. So out of all the fairy shrimp species that can be found in this particular region of the United States, the versatile fairy shrimp is the one that needs the least specific conditions in order to grow and thrive and proliferate and everything. They can tolerate wide ranges of water quality and you know, other environmental factors that might limit other species and everything. I mean, you can see out here, like this area has obviously been affected by, you know, anthropogenic influence and everything. It's been cleared by tractor equipment, and all these depressions that fill up with water are essentially new. And it's kind of no wonder why this species makes its home out here in these puddles. And to be honest, they might not have been here naturally. They were probably transported here on tractor equipment that might have been doing some work out there in their native range. You know, they're going through ruts, going through other puddles, and some of that mud that carries the eggs got into the gears and everything. And then they come out here on a new job site and basically drop those eggs. And the depressions that are created here fill up with water and then start the cycle of this vernal pool system with these as the favorable species within these conditions. So the second organism that is curious are those little bean looking things kind of floating around, just kind of like cruising around like little jelly bean spaceships and everything. So those are another crustacean in the class Ostracoda. Common name of that class is seed shrimp. And they are typically this size. You know, actually looking at these are pretty big now that I think about it. The largest ostracod is a marine ostracod that can be found in deep water marine systems, and it's about the size of a ping pong ball. So that is absolutely enormous compared to these. But ostracods are very common crustacean organisms found in a wide variety of aquatic, freshwater, and marine ecosystems. And again, not surprising to see these here in these modern day vernal pool systems and everything. Okay, so the next one up is that kind of like squiggly caterpillar looking thing. So I'm not sure what species that is, but I am positive it is in the family Syrphidae, or the family of hoverflies or bee mimicking flies. I'm sure you've seen these flies before, at least the adult forms, in and around your house. Those are the flies that kind of like hover in one place. Oh, by the way, it's an insect. It's a fly, Diptera, order Diptera. You can see at its posterior end, it has that kind of like long, almost like rat tail siphon appendage. And that's actually what it is. It's a siphon for air, so they can stick that out above the surface, grab oxygen, and essentially use it to metabolize. Yeah, surfers are actually known to live in really, really shitty water conditions, or really, really bad water conditions. Is it a surfid? Hey, is it a surfid? Oh, I'm questioning now. And you know, it's no surprise it's found in these puddles, because the conditions here aren't that great. I mean, they're good enough to support these, that's for sure. And the last one, the most quick one, that one's swimming around right there. That is also another insect, but it's in a different order. It's in the order Hemiptera in the family Coryxidae, which is the common name of the coryxids are the water boatmen. Maybe because they superficially look like they're paddling a boat. But yeah, these are a hemipteran, so they have those styloid, hausolate mouth parts, you know, those piercing and sucking mouth parts and stuff. The hind legs there have evolved these natatorial structures that make it easy to swim through the water. And as an added bonus, they have wings, and they can fly. So when this puddle system dries up, they can just fly to a new puddle. And I think they're omnivorous, like they can eat vegetative matter, or at least some species eat vegetative matter, and some are predatory. They'll eat other things or other animals. But yeah, so we got 2 taxa classified as crustaceans. And technically all 4 of the taxa that I talked about, they're technically all within one major group called the pancrustacea. So the division of organisms we know as crustaceans it isn't as simple as we thought. You know, there's a lot going on there. There are some taxa of crustaceans that are more related to other taxa that aren't considered crustaceans, you know, like these fairy shrimp. They're showing that they're probably more related to insects than they are other crustaceans. But I think it's cool and wildly amazing just kind of staring at this. Essentially, you're looking at a window of arthropod evolution all in this one watch glass. Anyway, I'm gonna dump these back in the puddle because I gotta get out of here. All right, so walking these things back to their puddle, you know, I can't help but think, like, you know, what if this is sort of like a new ecology, you know? Like, what if the species that I'm finding here, because the conditions, you know, compared to what we look at in, you know, very pristine conditions, these conditions are pretty ass. However, we have examples of organisms that are taking advantage of ass conditions. And I can't help but think if this keeps on going on, it'll end up creating a speciation event or something like that. Like we'll get urban or suburban fairy shrimp. Because when it comes to the insect taxa out here, the coryxids and the surfids, those are basically already established as cosmopolitan. You know, they can be found in many urban environments, suburban, you know, fringe environments and stuff like that, and as well as in natural environments. But the fairy shrimp, you know, they might have what it takes, you know, genetically, to kind of make it through the metaphorical wildfire, if you will, of human existence on this planet. But you know, it appears that's just what life does. If life adapts, it adapts, and so be it, in my opinion. But anyway, that was just my little food for thought kind of spiel type thing. All right, back to your universe. So I think that about does it for me out here. I've spent enough hours out here, and I've been seeing people drive by and look at me like some kind of weirdo digging in the puddles and playing around. Little do they know, I think that they're weird for looking at me weird, because they ain't seeing what I'm seeing. But anyway, I just want to express my appreciation again. Really appreciate you watching, all 20 of you. And still planning to come out with some more videos, so be on the look for those. And with that being said, keep your decisions scientific, stay away from all the gimmicks. I'll make a bot slice. Peace up, peace out. Go on and learn something.